Good morning, everybody. Welcome to the webinar of Mold Tooling Design with 3D Experience Part 2. So my name is Nagarjun. I am Assistant Manager working in ALTEM Technologies. So today we are going to have a webinar on Mold Tooling Design with 3D Experience. This is Part 2, continuation of the Part 1. So this is our journey. The ALTEM was established in the year 2010, and since then we have had recognition from various companies with whom we have partnered with. We are having top customer support award from Stratasys, whom we are partnered for 3D printers. Then from the year 2019, we have been the platinum partners for Dassault Systems, and we are also gold certified partner for Ortec 3D scanner. So Altum, as I told you, it was established in 2010, and we are having multiple locations, offices in multiple locations in India, as shown in the slide. So our headquarters is in Bangalore, and we are having more than 75 associates working in our company. So we are having more than 500 plus customers across India. We deliver solutions as mentioned in the slide here. We address the PLM solutions, engineering simulation, additive manufacturing, reverse engineering, life sciences, and we have also set up supported by giving our solutions to COE and incubation centers also. So this is like what are all the products or what are all the services we provide. We are partnered with various OEMs, starting from Dassault Systems, Artec 3D, Stratasys, Selling, Hexagon, Intech, and Esteco Engineering. So we are having solutions in all the domains of mechanical industry, starting from concept design to detailed design to tooling and to aftermarket. For each of these domain, we are having unique products. For example, if you consider engineering, we are having design software from Dassault Systems, and we are associated with Stratasys for 3D printer activities. When we come for manufacturing, we have manufacturing simulation for robotics, and we have forming, welding, additive manufacturing simulation, composites, and 3D printer. So let it be any domain within the mechanical industry, we are having solutions to help them to achieve their goals. So we are also had multiple awards from each of the brands that we represent. These are partial list of customers. So we had a similar kind of webinar, Mold Tooling Design with 3D Experience Part 1. So I just want to have a recap of what was the Part 1 webinar about. So the first step was the selection of the main pulling direction. So I have taken an example of a pan handle, okay, and we are going to do the complete end-to-end detailed mold tooling design for it. So I have taken the pan handle design, and the first step which I did in the part 1, okay, part 1 of the webinar was we need to select the main pulling direction. Once the main pulling direction is selected, we did the sketching for the cooling channels. Okay. Then we did the drilled cooling circuit creation. Once the cooling circuit creation was done, we created bafflers and bubblers for the coolant channels. Once that was done, we created the ejectors so that the part can come out once the mold is prepared. So we need to create the ejectors. So that ejector creations was demonstrated. Then we gave the injection point. Okay. As you can notice in part 1, we are just setting the context. Okay. We are creating all the parameters. We are creating the ejectors, we are creating the injection points, we are creating the bafflers and bubblers. Okay. Once the injection point is created, there are options to create the runner part as well. Okay, so all that was displayed in part 1. Then once the runner part is created, we can assign the faces to core and cavity. There is a one click command where the model gets distributed into core and cavity, but that is system generated. But if you want to fine tune, okay, we want to additionally move the faces from core and cavity. That option is also available. Manually we can assign the core and cavity, certain faces of the part to core and cavity. That is what is demonstrated in the part 1. Once the core cavity and the slider faces are assigned, then we need to create the slider. So in part 1, we have demonstrated, or I have demonstrated, how slider can be created. So once all these things are set, the next thing which was demonstrated was how to create a parting line. There is a very easy option available in the software. Just by push of one button, the parting line gets created. Then the next step would be obviously to create the parting surface creation based on the parting line which was created. Once the parting surface has been created, we have ended the part 1 by creating the inserts. So as you can see, this is the standard approach which Dassault systems will want us to follow. But anyways, we can customize this. We can use our own approach, okay? Because different companies will have different standard procedures which they would like to follow. But this is what this 3D experience is, a customizable approach from conceptual to detailed mold-to-link design. So in the part 2 of the webinar today, which I'm going to demonstrate, we will be starting from inserts creation, and we will do the complete mold-to-link design. And we can go through that webinar completely. And at the end of the session, we can answer some of your queries which you might have. Okay. So let's start with the today's session. So I am starting the today's session. Okay. Thank you. Hello everybody. Today I am going to demonstrate the second part of the mold tooling design. In the first part, we have seen the detailed core and cavity design for a panhandle. I am going to continue from where I ended in part 1 when we created the empty insert unit. Now here I am hiding the design input data. Now that the insert unit is created, we need to activate mold project unit and click on the update button. Once it is updated, we need to create multiple layout by clicking on the multiple print layout in the mold structure section. We will select rectangular pattern x is equal to 2 and y is equal to 1. Select the left print and rotate 180 degrees. Next, we need to create a mold base, and before selecting the mold base, preference setting needs to be changed. Once the preference is changed, we need to activate mold project and select mold base configurator command. Here we can edit the mold base as per the requirement as shown above. We can edit each and every part of the mold. Next, we need to create impact of core and cavity inserts on the core and cavity plates. This will help us to detect clashes with components in design context and creates an impact. We will go to the mold design and select the component impacted by components icon. Here we can select which of the portions that can have an impact on core and cavity plates. I am removing the coolant and the running in this case. Now we will open the core and cavity plates in a separate app to check what is the impact on those parts. This is the cavity plate. Next I am going to open the core plate to check the impacts on the core plate. One of the most important feature in 3DExperience mold tooling software is that we can able to create conformal cooling channel very easily, which has an effect on the output of the molded part when compared to the standard cooling structure channel. The cycle time of the entire process also is reduced by adopting conformal cooling channels. For creation of the conformal cooling channel, we need to extract the proper surfaces and project the cooling circuit which will be created as shown. Once projected, we can set the diameter as per the requirement. Here I am creating a plane on which we will be creating the cooling channel. Now we can sketch the cooling channel as per our requirement as shown. Now once the cooling channel is created, I will project the cooling channel onto the surface of the mold. Now you can see a conformal cooling channel has been created. Now we can set the diameter as per our requirement. In this case, I am selecting diameter as 6 mm. Now the next step is to create various mold tooling element. First, let us create the bushes, for which we need to create geometrical set under core plate and sketch the points on the exact position where bushing should be placed. I am creating a geometrical set under core plate. Creating sketch and sketching the points for the position of the bushes. Once the points are sketched, we go to the define component specifications under mold section tab and select the bushing type and select the specification as select pattern and select the sketch where we had created the points. In the similar way, we create sketch under cavity plate and create 4 points for the leader pin and select the leader pin in the define component specifications. Now I will go to the define component specifications and here I will search for leader pins. In the specifications, I will go for selection pattern and select the sketch. For the cap screws, we need to create points in the sketch under setting plate in the mold and select cap screw type in the define component specifications. Here I will search for cap screw and select selection pattern and select the sketch. We need to create cap screws even in the cavity plate of the mold. So I'm going to create a new sketch and create points for the position of the cap screw. Once the specifications are set, we need to replace them with the desired size and make of the actual components from the browser library of the Molten components. First I will go for the pushing, place components on the search, and select the pushing. I am going to reverse their position. There are options available. Now the pushing is replaced. In the similar manner, we can replace the actual components of the leader pins also. As with the previous case, there are options to change the orientation. Now we need to replace the cap screws also. Here I am reversing the orientation. We can move the components by using the move components icon. Once we move and update the impact features in the mode base also gets updated. Also, the components will move with respect to the anchor points either away from each other or towards each other. Here I am moving the pushes and the leader pin. I will go for the individual move option here. As you can see, both the push and the leader pin are moving in the same direction. Now I am going to check the movement of the leader pins. To see how they are moving with respect to each other. In this case, the two cap screws are moving away from each other. Next, we will see how various cooling circuit components are created. We will open the core print in the separate tab along with the cooling channels. we go to the drilled cooling circuit tab and set the parameters as shown. Then we select the two cooling channels and define the component specification and select the O-ring for the particular two cooling channels. We need to change the parameters for different components. Now I am setting the components for the connector plug component. We will select the cooling channels and define the component specifications and create cooling connector plug as the specifications. I am changing the drill hole parameters for a different type of connector. Different type of connector plug. I am selecting the required cooling channels and selecting the connector plug. Once the specifications are defined, we replace with the required size and make of the cooling mold components from the browser library of the mold tool cooling components. Here I am replacing the O-ring. Now I will select the connector plug specifications and replace them with our required connector plug from the voltage library. replacing the components with the connector plug. In 3D experience, we are having options to edit the individual motor components to our required size and specifications. Here I am creating a point in the axis system on the part so that it can sit at the proper position when I am inserting into the mold base. Now I will replace these two connector plugs with the required connector plug. As you can see, all the connectors have been positioned. In the similar manner, there is options available to create and position all of the mold tool components in the 3D experience. Thank you. Yeah. So now the part two of the webinar is complete. With this, the end-to-end process, okay, of the entire mold tooling design with 3D experience has been demonstrated. So just for the people who have not seen the part one, you can see the link here. It's on our ALTEM page YouTube channel. You can go through that part one in case like if you are missed to see that webinar, and this was the continuation of this part one of the webinar. So we will share this link with all the members who are attending this webinar so that you can go through that part one, and you can also, this will be live after this session in the YouTube. Part one and part two both will be available in our YouTube ALTEM channel page. So I hope this session was informative. So we are open for any questions. So anybody who has questions, you can ask us here in this forum, either through, I think you can type your questions in the chat window and we will take up all the questions. So Shital, if you are there, can you read out the questions if any persons has put up their questions in the chat window?
Yes, sir. So we do have certain questions.
Okay.
So the first one being, what are the considerations
Okay.
for designing composite models and implementing closed tool molding process?
Molding of composite.
Yes.
Okay. So first and the foremost, like while you are taking the input design, okay, based on the material which you are considering, there is an option to create the shrinkage factor, because depending upon the material which we choose, the material will either expand or it will contract upon the completion of mold tool. So that consideration can be taken in the first step of the mold tooling itself using the software. You can give the shrinkage factor, and for other considerations there are options, but it depends upon case to case. There are several options available. So this is a so if I can get like what are the other considerations which you're looking for, we can discuss one on one, like what are the considerations and what are the options available in the software. So for that, we can connect one to one so that we can answer all your query.
Okay. Thank you, sir. So the next question is,
Hmm.
how can they perform press tool progress design, strip layout, and part analysis?
No, this is not the webinar for press tool design. This is mold tooling design. So I think that will be that question is not to answer in this session.
Okay. So, in case if you are doing any further sessions, we can invite them as well, no, sir?
Sure, sure, yeah.
Okay. So the next is again, how can one create a die tool and add it to the tool library?
Uh, like you mean the mold tool if you want to add it to the
Yes.
library? Yeah, you can create a mold tool and you can add it to the catalog, and it gets stored in the catalog, and whenever you want to use that particular mold you can pull it in from the catalog. So that process we can demonstrate, no problem, that options are there. In the interest of time, we are not demonstrated here, but we can connect one on one and we will show you the options, and that options are definitely available in the software.
Okay. Thank you, sir. So the next question is, how can surface modeling be effectively utilized within CATIA V5?
Yeah. So for that, already there's a webinar which we have demonstrated. So Shital, make a note of this customer. I
Okay,
will
sir.
share the link. You can share it with the customer so
Okay,
that
sir.
they can see how the surface design is possible with CATIA V5 and 3D experience. We have both the webinars already hosted on our YouTube channel.
Okay, done. So these are the questions, sir. So done.
So any other questions, you can connect back with us, and we will be happy to answer all of those queries. And as you are aware, this Dado Systems 3D Experience software is a very popular software, and uh, uh, to the best of the knowledge, Dado Systems has taken into all of the industry standard practices, and they have tried to fit in into the software. But in case some options or some features which you might require, okay, the options is not there, you can let us know. We can discuss one on one, and we can check with Dazo as to how those options can be tailor made for you, and we can definitely help you. So the 3D experience software, it covers mold tooling design, from encompassing all the features and all the capabilities which are required for a design engineer. So if there is no other questions, then we can end the session, and you can come back to us anytime. And Shital, make sure that all the people who were present here, we need to share the link for the part one so that they can go through at their convenient time.
Yes, sir. Sure, sir. So also we just have a message saying that thanks to ALTEM team for arranging webinar on mold tooling with 3D experience CATIA. Much needed.
Yeah. Thank you for that.
Thank you so much,
All
sir.
right.
Thanks a lot, sir, for the amazing session.
Yeah. Okay.
Thank you, everyone. Thanks a lot. We hope to see you in our upcoming webinars as well. Thank you.
Thank you.